Now, now what we're going to do is we're going to finish off the questions in this lesson by creating some equations given some information. So we want to create a function that has a vertical asymptote at x equals 2, a point of discontinuity at negative 2 comma 1 over 2, and an x-intercept at 0. The first thing that I'm going to do is I'm going to look at that vertical asymptote. So that vertical asymptote is going to give me the x minus 2 in the denominator. Then we look at the fact that my x-intercept equals 0. So that means that I'm just going to have an x value on top. Now, before I include this point of discontinuity, I'm just going to check to make sure that this point works and I won't have to introduce a constant value into my numerator. So I'm going to go, well, y equals 1 over 2, and I go 1 over 2 equals negative 2 all over negative 2 minus 2, and I get 1 over 2 equals 1 over 2. That tells me that I'm not going to have to introduce a coefficient or a constant value into my numerator. So all that I'm going to do is I'm going to include that point of discontinuity in here. So we get y equals x all over x minus 2. Oh, I'm just going to rewrite that actually. It's a bit messy. Apologies about that. So I get y equals x all over x minus 2. I see that my point of discontinuity occurs when x equals negative 2. So then we're just going to go x plus 2 all over x plus 2. Moving on, and again, if you guys want, you can try these out on your own and then look at my solutions. We have vertical asymptotes at x equals plus or minus 2, no point of discontinuity, and an x-intercept of 0. This one's actually going to go pretty fast. So I get the x plus 2, x minus 2 in the numerator because of this point right here. And I have an x-intercept of 0, so I can place the x in the numerator as such. A point of discontinuity at 2 comma negative 3, a vertical asymptote at x equals 3, and an x-intercept of negative 1. So starting off, this is going to give me the function y equals, my x-intercept is negative 1, so I get x plus 1 in the numerator. From there, I have a vertical asymptote at x equals 3, so I'm going to get my x minus 3 in the denominator. Now I'm just going to rewrite this a bit less messy. I apologize. Again, I am still getting used to this whole virtual world that I'm currently living in. So at this point right here, we're just going to test to make sure that this point works before we insert the point of discontinuity. I go negative 3 equals 2 plus 1 all over 2 minus 3, and I get negative 3 equals negative 3. So that works out perfectly. As such, I am just going to include my point of discontinuity into this, so it'll be that x minus 2 factor, and what I'm doing to the top, I'm doing to the bottom there because it has to cancel, and we get the x minus 2. Finally, ending off, we get y equals, and looking at my top, I have x-intercepts of 1 and 4, so x minus 1, x minus 4, and looking in my denominator, I have the vertical asymptotes at negative 1 and positive 2, so it'll be x plus 1 and x minus 2. As such, my function is done. Now, if you guys look, please give this homework a try for this question. And from here, we will move on to the third lesson in this